I have shown you evaluation sheet for the jig. Then we have already discussed the tips for selection of the jig, and we were discussing construction of the jigs, drill jig. These are the various type of jigs: plate jig, angle plate, turn or jig, box jig.
सर आपका स्क्रीन विजिबल प्रेजेंट नहीं कर रहा.
Oh, oh, sorry. So out of this angle plate jig, turn or jig, lift jig are more commonly used. So the template jig was discussed. It is not much used, template jigs. And we also discussed that locating pads can be used to reduce the support. So instead of giving the support over the entire base, you can give localized support. Either 4 or 3 are sufficient. So this is how you can clamp it, and in order to reduce the mark, you can use some pads of softer material. If this surface is finished, you have to protect this surface from the marks. These are the various jig bushes, and if the bushes are closed, if the holes are closed, they may not be able to accommodate this collar. इसको collar बोलते हैं jig bush का. एक दूसरे को touch हो जाएगा. So we have seen how the bushes can be combined in case if the holes are closer to each other. This was a channel drill jig. Through and through the workpiece can be inserted, that is perpendicular to the screen of this plane. So you need to have some अटक, आपको एक अटक देना है, so where it will rest. This is the blank of workpiece, blank of the workpiece. WP मतलब workpiece, blank मतलब before drilling the hole, that is called as the blank. Gear teeth blank, that is before cutting the teeth, we call it as the blank. Okay. And then final workpiece means it's with the drill hole. The hole has been drilled here. Then we have seen how the locating post can be used for locating. Again, some area is reduced because instead of, see, we always try to reduce the area. So instead of giving support, let's say suppose if this length is say 100 mm, so no need to locate the entire 100 mm. You can locate two ends. So just finish the surface 10 mm here and 10 mm here. So that is sufficient. And जो बीच में का जो 80 mm है, that you can relieve, वो undercut करने का like this. Okay. So that or this particular design will give you a good grip. So instead of, हम लोग को ऐसा लगता है कि पूरा का पूरा 100 mm पे सपोर्ट करेंगे, but no, even at two ends it will give better, so this reduces actually the manufacturing cost, because suppose if this hole is finished 100 H7, 100 plus 0.02, and you are making locating post, तो locating post अगर आप 100 बनाना है तो पूरा का पूरा 100 mm लेंथ आपको टॉलरेंस में बनाना पड़ेगा. बट इफ यू आर ओनली making this 10 and this 10 in tolerance, then the बीच में का है you can relieve it. So बीच में का you can make 99, I mean suppose if the diameter is 25, you can make this 24 or 23, and this may not, it is not required to have tolerance. So your manufacturing cost reduces considerably. So now in this case, this hole can come at any point because there is no orientation. ये जो hole है कहीं किधर भी आ सकते हैं, इधर इधर इधर, because there is no orientation and it makes no difference also. But if it has some fixed orientation, like say suppose if we have one hole here and one hole here on this face, and with respect to this hole, suppose if this hole is at the center of this, that is, or if this hole is to be drilled at 90 degree to this hole, like what I'm saying, suppose if you want to drill, if we have two holes drilled here on this face and position of this hole is given with respect to this hole, then you need to have orientation, you need to locate these two holes also. Okay, so on the jig probably you will have to give one more pin to locate the holes on the face, and then only you can drill this hole. Otherwise, while fixing up, just a minute. Hello, can you hear me?
Yes, sir.
Yeah. So now suppose if the orientation of this hole is fixed, then you, with respect to these two holes, then you need to take the reference of these holes in the jig. This component also we discussed. So before you start, you can take reference of this component. This is the angle plate jig, and we have seen how this rotation can be prevented. So turnover jig means you have to rotate it drilling. So here the component is loaded from the bottom, means first you have to rotate, you have to place it on this surface, then load this component, clamp it, then you turn it over down and perform the drilling through this bush. Look at this chain. This chain is holding the washer. Many times it is observed that while unloading, when you remove this knob, you have to take out this washer also, and many times it falls down. Our operator doesn't know where to keep it, and then after loading the component, he keeps on searching for the washer and for the knob. So it is a good practice to fix up the washer and the knob also with some chain or with some hook on the plate itself, so that it remains hanging there, and then operator doesn't have to search here and there, so that saves the time. So you have another type of jig, that is leaf or latch jig. Somebody has joined, I think. This is a component in your drill jig, like sectional drawing like this. This is what you have to submit, and plus a 3D model. You need to show the component, preferably use color, and you can use color in the software. This is a leaf or a latch, जो घर का लैच लगाते हो, and this is a hinge or a fulcrum about which this latch is rotating. So once the component is unloaded and then loaded on this locator, see, this is a locator, a round locator. Now again, here the location is only at this hole, so the component can rotate. Hmm. So there is no orientation of the component. It can be located at any angle. So if the position of these holes is important, then you have to be careful while loading the component. So this is the workpiece. When the workpiece is loaded, then you have to press this latch, which is rotated about the fulcrum, then bolt it. This is a wing nut. Wing nut, the purpose of wing nut or the knob is faster clamping. That is, it takes few seconds to clamp, and these are the bushes to drill the holes. Leaf or latch jig is also good, but over a period, the play is generated at this hinge and it loses the accuracy. That's why every 1,000 pieces or 500 pieces, you need to keep on checking the accuracy, that is the position of the hole, whether it is coming properly or not, because the hinge about which the latch is rotating over a period, it gets enlarged. So even if it enlarged by say few microns, you will get less accuracy. So that's a limitation of the latch jig. Pause jig is again like a box and you have a like a box means it is enclosed from all the four sides. So the loading has to be compulsorily from the top. The advantage of box rig is you can do drilling from all the five surfaces or even from the six surfaces also if you have holes. So in one time only you can drill all the holes on the surface. Like suppose now here this is a component, then this is a locator. Now see here in this particular component the drilling is done from this top as well as from the bottom also. So this is a bush as well as from the side also. So there is a drilling from the four surfaces. That is from the top. From the top you have four holes. Then from the bottom holes are not clear. How many holes are there? But this is a bush for the bottom. Then from the sides you have two holes here. That is nothing but these two. And again you have two holes exactly opposite to this. So that means this particular box jig, this is what the advantage of box jig is. You can do drilling on the four surfaces. The pod drill jig looks like a pot, and that's why the name is. And you can do drilling on the surfaces, and usually it is used for locating the outer diameter. So in this case, this outer diameter has been located in this pot, and these are the bushes. The six holes are drilled from the top surface, and it has been clamped in the center. In drilling, actually, you don't need much clamping because there is only one force in drilling. You have to remember, and that is what is nothing but axial thrust. Drilling में there is only one force, that is axial thrust. एक ही force रहता है drilling में. That is what is called as the axial thrust. This force is called as the axial thrust. So when you are doing the drilling, that time the component gets clamped. This is your axial thrust. While in case of lathe and milling, there are three forces. This is your handwriting is poor. In case of lathe or milling, there are three forces. That is forces in x direction, in y direction, and in z direction. Okay. So these forces are called as radial forces and tangential forces. So in case of lathe or milling, the clamping has to be.
आशीष।
आशीष सर को पूछना किधर गए।
सीआर को बोलना, मैं मेरे को क्या तेरे बोल रहा है।
नहीं सर का कैसा तू क्लोज है ना थोड़ा इसलिए भाई, सर अच्छे से जानते हैं तेरे को ना इसलिए।
नहीं नहीं, ये सब काम सीआर करते हैं।
क्या
तुम लोग पागल है कह रहे, तुम लोगों को समझ में नहीं आ रहा क्या, रिकॉर्डिंग वगैरह है चालू,
अरे
लेक्चर का
शरारत
इधर क्यों
शरारत
झगड़ रहे।
समझ चला रहे
पागल है
यार।
तुम लोग।
झगड़ कौन रहा है? हम लोग झगड़ कोई नहीं
समझ रहे
है।
हैं आशीष तेरे को कुछ।
अरे झगड़ नहीं रहे हम
नहीं,
लोग,
शांत बैठो
सर
शांत बैठो
दूसरे को
शांत
पूछ
बैठो
रहे हैं।
शांत बैठो।
Sir has network issue. He will join soon.
ओके सीआर।
Hello, there was a network issue. Any doubts about construction of this jeep? Hello? Yeah, any
Yes,
doubt?
sir.
I am audible, no, Sonia? Yeah,
Yes, sir. You are
okay.
audible.
So whatever you have missed, Sonia, you please, ask your colleagues. huh? And
Yes, sir.
and
I've
your
asked
group,
them.
I don't know what is the status. Have you studied the drawing? Because I asked to I asked to submit a
Yes, sir.
isometric view and the rough drawing of the jig. So please do that.
Yes, sir.
Okay, so
Yes, sir. We'll be submitting on
yeah.
next
So
practical, sir.
now,
And today we are going to work on this
okay.
completely.
So we will go for now fixture design. So first milling fixture design. Turning fixture is not there. So we will quickly go through the milling process. This is a workpiece to be milled and this is a milling cutter. So this is your horizontal milling machine.
Sir, you are not present.
Hello? Because it
Sir, you are
was
not present.
connection was lost. Yeah. So before we go for the milling fixture, we'll first understand the milling process. So this is a workpiece and this is milling cutter. These are the various operations which can be done. So what I was telling here, this is your horizontal milling machine. This is a milling cutter, side and face milling cutter. And बघ चेक कर वरची ठीक आहे मी बघतो जस्ट अ मिनिट Hello. Yes, Sonia. Can you hear me? Yeah, the light has gone. Now let me
Yes,
see
sir.
now how long I can pull on the battery. Yeah. So these are the
Okay, sir.
various operations, milling cutter milling operation. So this operation is called as the peripheral milling. This is your face milling. This is end milling, which is more common, and this you don't have to worry. This we are using ball and mill. So only you have to remember this, and most of the time you will have to do milling fixture for face milling or for the slot milling. Uh, Most of the components what you have, that is face milling or end milling. So there are two types of milling. One is clamp milling, that is also one of the conventional milling, and then another is down milling. Clamp milling is also called as the down milling, and another is up milling. Okay, so this is down milling. Now you can see how the cutter is rotating here. The cutter is rotating like this. Okay, and the feed is in this direction. So ये जो है, this is your down milling. Now here you see the cutter is rotating like this, that is ulta, like this, and the workpiece is fed in this direction. So this is for the up milling. So the purpose of telling this, because when you are making milling picture, you need to identify the kind of operation. Because if it is up milling, then in up milling the cutter will try to lift the workpiece. If it is down milling, cutter is rotating like this. So in this case, cutter will try to clamp the workpiece. It is forcing down. Workpiece is being forced down. So here the clamping requirements will not be very high. Whereas here, since the cutter is trying to lift the workpiece, you will have to clamp the workpiece strongly. So first identify whether you are going to do up milling or down milling. If it is up milling, so instead of 2 clamps, you need to provide 4 clamps. If it is down milling, then 2 clamps are sufficient. So conventional milling is called the up milling, and clamp milling is called the down milling. So here this diagram is up milling and this diagram is down milling. So in MCQ it is asked the other name for the conventional milling or other name for the climb milling. So even though you have done it, this is just for the refreshment purpose. These are another operations, like this is straddle milling. So in straddle milling, this T shape is generated at a time. So advantages will be the machining time will be less. Plus, since you are doing this in one setting, you get good accuracy. This is a form milling, like you are generating a convex surface on the workpiece. So you have concavity on the cutter. So your cutter is concave, so that your workpiece will be convex. This is slot milling, and this is slitting. So the difference between slotting and slitting is, in slitting there will be 2 pieces, and in slotting you have a blind pockets or a blind slots. So slitting is generally done with the help of a slitting saw, because your material should not be wasted. So generally 3 mm thickness slitting saws are used. If you try to use thinner saws, then there is a tendency that this saw will break. These are the type of the milling machines, because we should have a background of or refreshment about the milling machine also. So this is your column and knee type milling machine. Before you make milling fixture, you have to identify whether it's going to be horizontal or vertical milling machine, and accordingly you have to design the milling fixture. And you know how the feeds are. So this is your longitudinal travel, and this is your cross travel, and this is your vertical travel. So in this case, the feed is given to the table, and tool is only rotating. So this type of machines are suitable when your workpiece is not heavy. But if the workpiece is heavy, like suppose if the weight of the workpiece is 1 ton or 2 ton, like your dies and molds, where the blocks are 500 kg, 1000 kg. So that time what we do, we keep the workpiece stationary, and the tool is moved in all the directions. The tool, cutting tool is moved in all the directions. Imagine a 1 ton block, if you have to move in all the three directions, then corresponding HP of the motor will be very high, and the structure of the machine will also be very high. So the machine will become heavy duty. So to make the design of the machine simpler, that time we go for fixed bed type machine. Very important question from Y1. So fixed bed type machine में your bed is not moving, your bed is stationary. All the X, Y, Z movements are given to the cutter, and of course the cutter is rotating. Okay, so fixed bed type machines are used for machining heavy components. You have to design a milling fixture for the same component which you have taken for the jig design. So these are some milling fixtures. So when you are designing drilling jig, that time itself you have to give thought for the milling fixture also. So fixtures are basically heavy. Now this is side and face milling cutter, and this is being done on horizontal milling machine. The spindle is like this, horizontal. This is the base, and we generally take a setting piece for setting the height of this milling cutter. We don't change the height of the milling cutter every now per component, per workpiece. The milling cutter remains at a fixed height. That is, इसका जो डेप्थ करना है, इसमें जितना डेप्थ करना है, वो डेप्थ में हम लोग मिलिंग कटर को सेट कर देते हैं. तो अपने को कटर ऊपर नीचे या वर्कपीस ऊपर नीचे करने का जरूरत नहीं रहता है. तो आपको खाली यही डायरेक्शन में फिर देने का, एंड जो स्लॉट है वो कंप्लीट करने का. सी दिस, सपोज इफ दिस इज द डेप्थ ऑफ द स्लॉट, दैट इज से 10 mm, फिर आपका जो मिलिंग कटर है, यहाँ पे जो आएगा मिलिंग कटर, वो जो मिलिंग कटर है वो ये हाइट पे लाके रखने का, ये हाइट पे. So this milling cutter you are not supposed to, your आपका spindle है, this cutter is rotating, preferably down milling. So ये cutter को up down नहीं करने का. This motion is avoided. So the cutter will only move in this direction. Sorry. And as far as possible, you have to assume the width of the cutter to be equal to the width of the slot, so that you don't have to move this cutter in y direction also. Y direction also, you are not supposed to move the cutter. So only in this direction you have to move the cutter. So z axis में भी cutter को set करते हैं, that is this. यहाँ पे ऐसे एक setting block लगाते हैं. This is called the setting block, which is kept on the table. ये table है और इस setting block के ऊपर milling cutter को set करते हैं. And then once the component is loaded, we simply move the cutter in longitudinal direction. See, now this is a better view. See how the component is loaded. This is the setting piece. This is the slot to be milled, and these are your clamps. Now here again the location in this direction is important. This, the component has to be located properly in this direction. So you need to have a support, yeah, either from here or from the back side. हाँ बोलिए.
तो वो जो ब्लू
हाँ,
वाला पीछे
ये
सपोर्ट है ना,
this
ब्लू पार्ट,
तीन जो ब्लू दिखा है वो,
लाइट ब्लू पीछे,
ये हाँ, दिस वन, हाँ
दिस वन, हाँ.
हाँ
तो वो भी साथ में मिल हो जाएगा ना,
हाँ, वो साथ में मिल हो
जब भी
जाएगा. यस, यू आर राइट. सेटिंग पे तो, लेकिन पहली टाइम है, देन दिस रिमेन्स सेम. हम लोग इसको लोडिंग और इसको हम लोग
क्या
अनलोडिंग नहीं कर रहे, इसको अनलोड नहीं कर रहे, इसको ऐसा ही रख देते हैं. अंडरस्टैंड नो, इसको निकालते ही नहीं है
यस
ये पीस को.
ओके सर.
This is a, this also I'll upload today. Rest of the things I have uploaded. So many of your milling fixture design will match as per this. So design procedure, width of the cut. Now here it is 3 mm. So you will have to take milling cutter of 3 mm wide. You have to first select the fixture, then how you locate the component, how you clamp the component, and then you have to design the fixture body. Here 5 workpieces has been located. 5 workpiece. But you have to design for single workpiece. As I told, the plate material is MS, and wherever the cutting tool is in contact, that material has to be harder. So it can go for EN24, EN36 or OHNS. That is oil hardened non-shrinking tool, OHNS. If it is up milling, then your clamping should be strong. If it is down milling, then clamping need not be very strong. because during the machining itself, the cutter tend to press the workpiece. It will not allow the component to lift up. So this is a supporting block on which your milling cutter height is set. Now this is another component in which through and through slot is cut. And you have one more milling fixture design for your reference. So this is a vertical milling machine. This is a cutter. आपका कटर है. And this slot is being cut. So the cutter is moving perpendicular to the screen. And this is how the component is hold, clamp, and located. So if you look in this direction, that is right hand side, left hand side view, look in this direction, then you will see this as a support piece, and this is your locator, and it will also act as a ejector. Generally loading and unloading is done manually in fixture because the components are heavy. You have to take care that this rotating cutter doesn't cut this piece and this piece. So this and this should be little inside. That is, if you see in this view, this locator, that is this piece and this piece should be somewhere in this region. यहाँ पे होना है, so that it doesn't touch the milling cutter, or milling cutter doesn't cut this. So that was just to give you idea, how the milling picture looks like. So whenever you are doing the drill jig, that time you also give consideration for the milling picture also. And then tomorrow we can start with the design of the milling picture. Okay. So if you have any doubt, you please ask. Okay. We stop recording. So thank you very much.